Hello all, welcome to session 29 of C#.NET training series. In this session, I am going to explain and practically demonstrate about typecasting in C#. So let's get started. First of all, I'll write a sample statement, say int a is equal to 9. Here, the literal type is int and the data type that is declaring the variable is also int. So when literal type has the same type and data type also has the same type, that is int and int, is there any typecasting required? In this case, no typecasting. No typecasting is required. No need to convert the literal type to the data type here. Okay. In order to store this value into this variable, it's not required to convert this literal type to the data type because this is int type only. This is also int type. Literal type is also int. Data type is also int. Fine. So no typecasting required. What if there is a situation where the left side part, the data type is different from the literal type? Yes, then something conversion should happen, right? What are the possibilities then? If literal type is different from the data type on the left side, then typecasting is required. But what are the different ways? There are three ways, guys. One is implicit casting. Second one is explicit casting. When the data type is different from the literal type, then we have to typecast it. Okay, simple, we have to typecast, but there are different ways of typecasting. First way is implicit casting, second one is explicit casting, and third one is casting not at all possible. You cannot convert a literal type to the data type. So these three possibilities I'm going to cover now. Okay, here typecasting is not at all required. This literal type is same and data type is same, not required. Okay, in this case it's not required. What if I write something like this: double b is equal to or a is equal to 9. Here what is happening? Literal type is int type, whereas data type is double type. They are different, right? But still, how this is possible? Because it is internally getting converted. This value 9 is getting integer, literal is internally getting converted to double data type automatically. And this is called as implicit casting. Typecasting is there here. Okay, here typecasting is being done, but it is being done in a implicit manner. Implicit typecasting this is. Okay, the literal type is getting converted to the variables data type, that is called as, when both are not same, when literal type is not same as the data type, then literal type will be internally converted to the data type. In case of implicit typecasting, you don't have to do anything here. Okay, so what are the examples here? Okay, how implicit casting is possible? Let me explain. When both types are compatible, here guys, in this case integer type is compatible with the double type. Okay, double data type. That's why implicit typecasting is possible. Not only that, that guys, here destination data type has a larger range. If you compare this integer literal with the double data type, which has higher range, double has higher range, right? What if I say something like this: int a is equal to 9.5? Is it possible to is implicit typecasting possible in this case? No. Here literal type is double, but data type is integer. Though the types are compatible, problem here is the range of this literal type is more than the range of the data type. That's the problem. That's why implicit typecasting is possible. Reverse is possible. If I say double a is equal to 9, this is possible because the range of the double data type is more than the range of the literal type, and also these two types are compatible. That's why implicit typecasting is possible. Other example for the implicit typecasting is long L is equal to 1 to 3. Okay, so here long L is equal to 1 to 3. Here literal type is integer, whereas data type is long. Both are compatible. Integer literal type is integer and long are compatible, and at the same time long has a higher range than the integer literal. That's why here also typecasting is happening. And which type of typecasting this is? Implicit typecasting this is. Okay, it is implicit typecasting, guys. Fine, guys, this is what is implicit typecasting. Now let me explain about the second type of casting, that is explicit typecasting. When the literal type is different from the data type, in some situations, okay, you have to do explicit typecasting, where I'll explain. For example, here if I say double a is equal to, sorry, not double a, if I say int a is equal to 1.25, what is the literal type here? Literal type is double. What is the data type? Data type is int. They are compatible. The data types are compatible. Literal type and data type are compatible. The problem is data type has a higher range than the literal type. That's a problem. In this case, we have to do explicit typecasting. Here, automate typecasting is not possible. Implicit typecasting is not possible, but we can explicitly convert. How? Just provide circular brackets here and provide the type of the data that you want to convert this explicitly. This double type, in order to store into the variable of the int data type, in which format I need to convert, which data type I need to convert, which literal type I need to convert this into double from to int type, right? I have to provide int here. Okay, inside the circular brackets, provide int. What happens here is error is gone. First of all, the double literal will be converted to the integer literal. That means decimal point will be taken off, and remaining one will be assigned to a. So if I print it out, CW and a console.writeline a. If I run this code, you see one will be printed in the output instead of 1.5, 1.25. You see one got printed in the output. Here what's happening is explicitly converting. You are explicitly typecasting. This is called as explicit casting, guys. Okay. When both types are compatible, double and int are compatible. Problem is data type has a higher range than the, sorry, in this case implicit, data type has a higher range than the literal type. But in case of explicit, when it is required, when literal type has higher range than the destination data type, in that case we have to explicitly typecast. Okay. So we have to explicitly typecast because here double is having the higher range than the int data type. So we have to explicitly typecast. Not only this, guys, double to float is also required. You see, if I say float f is equal to 1.25, here literal type is what? Double. Data type is what? Float. Float is 32-bit. Double is 64-bit. Okay. So this direct assignment is not possible. So what we have to do? That provide circular brackets, and here we have to convert the double to float first. Okay, double will be converted to float, then it will be possible. Okay, then it will be possible. Okay, so this is called as this kind of way of converting it. Okay, converting forcibly one literal type to another literal type for assignment to happen is called as explicit casting. And another case is also there where casting is not at all possible, no matter whether it's not internal, it's not explicit. Okay, it's not implicit, it's not explicit, nothing you can do to convert. Okay, so what is our example? For example, here int a is equal to true is there. Is it possible to assign a boolean value to the variable of the int data type? Not possible at all. Is there any way to explicitly typecast it, like providing int here? Is it possible? Still no. You cannot convert a boolean value at any cost to a integer value. Okay, integer literal, it is not possible. So this kind of stuff fall into the last category, that is casting not at all possible. When the types are not compatible, boolean is not compatible with integer or any other types. Okay, so it won't work. You see, bool b is equal to 9 also will not work. Reverse way. Okay, you cannot convert an integer literal to a boolean value, either implicit or explicit. Nothing is possible. So here, third case of typecasting is casting not at all possible. Okay, one case is implicit casting, other case is explicit casting. Third type is casting not at all possible. So hope guys you understood what is typecasting in this session. So that's all for this session. In the next session, I'm going to cover another C#.NET topic for you. Till then, see you. Bye bye.